Good evening, everybody. Welcome to the Expire Show, brought to you by Science Centre Singapore, the Singapore Institute of Technology and Aeronautics. Well, what will happen tonight is very exciting. It's going to be explosive. And I mean explosive means rockets, right? So we're going to meet up with Simon, and I'm not going to steal his thunder, and we'll go straight away to him and let him explain what explosion he is bringing. Okay, good. See you, Simon. Been a long time.
It's been a long time indeed. Prof. Neo, how are you?
Right. Yeah. So you have been building rockets.
Yes, and just to make it clear, explosion is something we actually try to actively prevent.
Control explosion.
Yeah, funny thing is that we don't actually rely on explosions with our propulsion. I'll explain a little more about that very shortly.
Okay, great. So let's then stick to rockets, okay? Sure. So I'll let you take over the show.
Sure thing.
Describe what you're doing.
So just a very quick introduction. My name is Simon, and I shall not bog you down with my surname, of course. I used to be a student of Prof. Neo in one of the technopreneurship courses over at the National University of Singapore, and we stayed in touch as fellow aerospace entrepreneurs this time around, which is really quite amazing.
But he has gone beyond me to space. I'm still in the aerospace.
Technically, we are, at this point, we are at 1.2 kilometers. You know.
Oh, okay, you're going to aerospace, yeah.
Soon enough, yeah. So in 2017, when I was still in university, I founded Equatorial Space, which became, well, I have no doubts, the leading launcher company in Southeast Asia, because there is not a lot. Yeah, and certainly we're the only ones here in Singapore. And we bring some very innovative propulsion technologies that I shall elaborate about very shortly. So aside from Singapore, we also have presence in Thailand, in Australia, and we are expanding quite aggressively into the United States. And I wish I could share some very good news with everybody today, but unfortunately, I'll have to wait for another month or so with regards to that. So here is the deal about rockets. And Prof. Neo, you were absolutely 100% right. That's what people think about when they see a rocket. It can blow up, right? And it's quite difficult to make sure that it doesn't blow up, doesn't go kaboom boom, because rockets nowadays rely on an explosive mix of chemicals, with basically an oxidizer and fuel, which are mixed together at the right moment, and ignite it. And at that point, they basically produce an explosion, which produces the thrust, right? So there's really two kinds of, okay, I'll get to that very shortly. What we are doing is we build rocket systems that do not rely on that explosive reaction. We are much safer, and at the same time, we bring a drastically reduced level of complexity. And for the engineers among you guys, you will know that the moment you bring in complexity, you're asking for trouble. That's why simplicity is the best strategy. So there's two very popular type of rocket systems currently available. On the left-hand side, you can see the solid rocket motors. If you ever launch a firework, if it's legal wherever you are, then you've dealt with a solid rocket system. In a solid rocket, the oxidizer and fuel, the two things that the rocket needs to burn together to produce thrust, are already stored together in a solid form, as the name, of course, suggests. The benefit of that is that those systems are very straightforward. There is no moving parts in its most basic form, but unfortunately, well, they are very explosive and very dangerous to handle. It takes plenty of precautions to make sure they don't go kaboom boom during the manufacture process, in storage, and during transportation. Also, solid rocket motors cannot be actively throttled in flight, which means they are mostly good for what we call boost phase, or the early phase of the flight, where you're just building a velocity, you don't have to shut it down or modulate it at a very specific point of time. And unfortunately, that is why they are not exactly very useful for commercial applications. They are very good for military applications, but not necessarily very good for commercial space launch. In the center, you can see a very simple schematic for a liquid rocket system. That's what SpaceX uses. That's what most of NASA rockets use. That is what a bunch of smaller companies like Relativity, Astra, Rocket Lab, all of them are working on liquid propulsion because it's very well understood, but unfortunately it also is pretty complicated. In a liquid rocket system, The oxidizer and the fuel come in a liquid form, and they require a very elaborate system of pumps to be delivered to the combustion chamber where the ignition takes place. What we are working with is known as hybrids. And hybrids rely on liquid oxidizer and solid fuel. And this is a very, very important distinction. We do not use solid propellant, we use solid fuel, because it is not pre-mixed with oxidizer. It is non-explosive by itself, and technically speaking, we do not create a detonation inside of the combustion chamber. What we create is deflagration. We burn it at a rate which is almost comparable to having an explosion inside. But the TNT equivalent is 0. That's how we can deal with this stuff in Singapore. I mean, in Singapore, even a firework requires a license. And here comes this guy and says, oh, I'm going to build launch vehicles. Hey, that doesn't compute at all, right? Yeah, right? But this is a bit of a loophole, you know, because hybrids don't contain anything that's controlled. And that is the beautiful thing. For oxidizer, we can use liquid oxygen, which is very much the standard, but we can also use a bunch of other things, like nitrous oxide. That's what we've been dealing with recently. And the beauty about hybrids, aside from the safety, is that they are very straightforward, because the only thing you have to supply into the engine is the oxidizer. So you have the amount of all that supply equipment that you need to put on board. And on top of all that, you can actually throttle that stuff, and you can shut it down if necessary, even restart it in flight, which makes them very flexible.
Can I ask you one question? Just
fire away.
So you came up with this idea.
No. We did not invent hybrid rocket motors, okay? So, right, I should have, yeah, so hybrid rockets have been around for quite some time, in fact. They've been around since the 1930s. And the reason why they never found their commercial applications as well was because of the solid fuel characteristics. Solid fuels were simply not good enough to be comparable with liquid and solid propulsion. And if you take things like polymer fuels, which are very nice and stable, they don't burn very fast. And you want them to burn fast enough to produce a certain degree of thrust. Wax-based fuels like paraffin wax are very commonly used in academic applications, because you can get paraffin wax out of anywhere in the world very cheap, but they are notoriously unstable. Paraffin wax just starts to slump the moment you expose it to a heating source. And when the vehicle is accelerating, it starts to fly out of the nozzle without being fully combusted, which is what you want to avoid. This is where we step in with our core innovation, the HRF1 solid fuel. Shout out to Jamie Anderson, my CTO, the genius who made this fuel work, and he developed that by himself a couple of years back. It offers us a very high burn rate without sacrificing structural integrity. And as a result, we essentially have a solid fuel that makes a hybrid rocket system with all of its benefits competitive with liquids and solids, without being either explosive in nature or very complicated. So where do we stand right now? We consider ourselves to be a TRL 5, and I can proudly say we accomplished that with just slightly over $500,000 in funding, which, well, yeah, a lot of, for a rocket company, that's basically pocket change. Yeah, and we were forced to survive through some really nasty stuff. Yeah. You know, you don't want to know what we had to go through to get this rocket launch in Malaysia in the middle of COVID-19 in 2020, with all the travel restrictions going on. To the very best of my knowledge, and I apologize if I'm wrong to whoever might have beaten us to that, but to the very best of my knowledge, that was the very first commercial rocket launch. I mean, a launch of a commercially developed prototype rocket in the history of Southeast Asia. And even though we didn't go very high, this rocket has proven that this solid fuel works beautifully and very reliably. It doesn't fly out of the engine uncombusted when the vehicle's accelerating. And moving forward, okay, so this is where I would like to come back to Earth for a second. We're talking about rockets, and rockets are all about access to space. But I would like to draw one simple comparison. As I was saying, we did not invent the hybrid rocket motors, the same way that Tesla did not invent the electric car. Electric vehicles have been around since the 19th century, late 19th century, actually. Yeah, but they were never competitive with gasoline guzzling vehicles, because of battery technology and the energy density of batteries back then, until lithium-ion batteries came on board. And HRF1 will be to rocket propulsion what lithium-ion batteries are to electric cars, and we, as an extension of that, will become the industry standard for rocket propulsion in commercial launch. Just like Rolls-Royce is the industry standard for jet engine propulsion. And on top of that, we're building a whole fleet of different vehicles that will be able to go into both suborbital and orbital launch. And well, that basically is pretty much it. Thank you very much. And if you'd like to stay in touch, please check out our website, www.equatorialspace.com. We have, of course, our social media. We have YouTube, Facebook, Instagram, and LinkedIn, and Twitter. So please follow us and stay in touch. Don't be a stranger. If you have any questions, just drop us a note anytime. And yeah.
All right, thank you very much. It's a very brief but very intense overview.
Yeah.
Maybe we can step you slowly through the whole process, right?
Yeah, it's a lot to talk about in this.
When you were studying under me, taking one of my class, what's your major?
My major is actually project and facilities management.
Yeah, project and facilities management, what I call real estate.
Yeah, well, I'm still working in space, just different kind of space.
Okay, so why rocket? I mean,
Well,
you work on this before you graduated?
Yeah.
Yeah, so why rocket?
You know, I think everyone has a rocket phase
Yeah.
in their lives, but
Yeah.
some of us just refuse to grow up, and you know, then we end up starting rocket companies. Yeah, I mean, honestly, that's actually pretty true because I was long interested in space tech, you know, and
You come from a family of?
no, my father's a pilot.
Your father's a pilot.
Yeah,
Is that
so
the inclination?
That's the only way I can beat him, and go
Okay.
and build up on where he is right now.
Yeah.
Yeah, so you know, I was growing this, you know, environment kind of permeated with aerospace already, right?
Yeah.
Right from the start. And you know, one of the movies that I liked the most when I was a kid was Apollo 13.
Apollo 13.
Yes.
Right.
Yeah, and I was watching that thing over and over and over again on a loop when I was 5 or 6 years old. And at that point, I already knew that at some point in the future, I would like to get involved with not just space, but specifically with launch. With the launch segment. And one thing led to another. We've been moving around quite a bit. You know, my father was taking up jobs in a few different countries, and we ended up here in Singapore. At that point, we decided to settle down. I was 15. I had to put my rocket ambitions on hold for a while because, you know, I had to go through O levels, A levels, then I did my national service and all of that. And when I was in university, I was like, okay, if I don't get started on this now, then I probably will never have a proper chance anyway. So I've connected with the local space tech ecosystem, Singapore Space and Technology Association at that point was instrumental to that. I was volunteering for them for a number of events, and I'm actually going to be speaking at their conference next week. So talk about an ascended fanboy. Yeah, and as a result, I was able to talk to people who build satellites, and I started hearing their pain points. If you have a small satellite, and satellites have gotten really small, you know, you should get some of the CubeSat people here sometime to talk about the current state of the art in satellite technology.
I'll get Zhening to come.
Oh yeah, Zhening would be fantastic.
Right,
yeah, and if you have a small satellite, no big launch service provider will really talk to you directly. You have to go through a brokerage firm, and they will charge you through the nose, and that is going to be a big problem. You don't really have a choice in your target orbit and your schedule, and that is the very principle why some companies have been starting up to provide so-called dedicated launch, which means it's a smaller vehicle, it's a smaller rocket with smaller payload capacity. Sure, it's more expensive on a per kilogram basis, at least on paper, but you get flexibility out of it. It's like comparing a motorcycle to taking a bus. Trust me, if you started riding and commuting by a motorcycle, you will never want to go back to taking a bus, even though it's more expensive. The time you save and the way you can just go from point A to point B is just amazing, and the same applies to launching small satellites into dedicated orbits, exactly where you want them to be.
Okay, you are running at rocket speed.
Okay.
I got to slow you down.
Please do.
Why? I observed something called Equatorial.
Yeah.
You somehow love this word called Equatorial.
Oh yeah.
Why?
Well, because we are 1 degree north of the equator, and equator is actually a very good place to be launching rockets into orbit from. You want a bit of a lecture on on orbital mechanics? Because I'm down. I can do it.
Yeah, but not an hour, maybe a 5 minutes thing.
Sure, okay. Imagine yourself on a very high mountain with a cannon, and imagine launching a cannonball from that cannon.
Right.
The faster you launch it, the farther away it's going to fly, right? It follows, it's logical. And if you launch it fast enough, it's going to go beyond the curvature of the planet and go all the way around the planet and return to the same spot, and that is an orbit. A lot of people confuse orbit with altitude. You only need altitude to escape air resistance, right? And the beautiful thing is, if you're launching eastbound, because the Earth rotates eastbound, you get some free velocity, because you already have some initial velocity coming from the rotation of the planet, Earth in this case, of course.
So it's like you...
Yeah, it gives you some free, you get a freeload on Mother Earth, basically. And the Earth rotates the fastest right at the equator. So that's one of the things that you benefit from by launching from the equator. The other thing that you get is flexibility in terms of the so-called inclination, which is the angle between the orbital plane and the equatorial plane. It determines your ground track. Essentially, gives you more flexibility. You can launch in any direction and go directly into the kind of orbit that you want to be in.
Okay.
Yeah.
So it's the best way to launch?
It's the best place, by far.
Yeah, okay, good. Now, let's move on, right? When you started, you have literally nothing, right? I mean, talking to you, and I can see a couple of volunteers walking in and out.
Yeah.
How do you convince people to join you?
Well, you know, this is where it's really important as an entrepreneur to have the right understanding of your subject. Right. Because even if you're starting off from zero, and we have started from zero, from nothing, you know, sometime down the line, I'll be able to share our paid-up capital, you know, in the original company, but it was not a lot of money at all.
Yeah.
But the thing is, I understood the language. When I spoke to experts in propulsion, I understood the value of hybrid propulsion. I understood the limitations of it. I understood the value of launching stuff from the equator because I studied up on the concepts in orbital mechanics by myself. And that is something you cannot delegate to anybody if you're a leader of an organization. You need to have the right concept and the ability to fine-tune that concept based on the senior people you attract into your organization. And I got a bit lucky, honestly speaking. Yeah.
So you got a lot of volunteers, as I see, right? So at the peaks, how many volunteers?
Yeah, we are actually moving away from having a very large voluntary group.
Yeah,
we're moving towards
in
the early days. At peak, we had 25 people, just contributing with whatever they could after hours. I am eternally grateful to all of them. But the most important development that we did was when we started bringing some senior engineers on board into the company. For instance, my current CTO, Jamie.
Right.
And we tried our best to get some functional rocket propulsion units built and tested on the ground. We were struggling with it, but when Jamie came on board, well, he brought 30 years of experience with him.
Yeah, nothing beats experience, right?
Nothing beats experience. Yeah, you have to.
So you have a burst of youthful energies.
Yeah.
And everybody's running in every place trying to figure out
It's like two curves, It's like two curves. You have your energy and your experience, and right now we're somewhere here.
Yeah.
We're running out of these.
But certainly it's not easy, right? When the two curve comes, somebody must have trust, experience one. Why would I bet my life and reputation on this guy?
Yeah.
Right. So at what stage that you?
Yeah, it's a gradual process. Yeah, so it's a gradual process because we started working with a lot of these senior people on a consultancy basis or an advisory basis.
Yeah.
And when they realized that, we are very earnest about what we are doing, that we have a clear-cut vision of what we want to accomplish, that we are ready to go out and try it and do our bloody best to fulfill that vision, at that point, they were enticed to join the company.
So they must have seen your vision.
Yeah, absolutely. And that's another thing that you cannot delegate to anybody else if you're running a company of that sort. You need to have a very clear, crystal clear vision into what is it that you want to achieve.
All right. So let's leave the vision aside first. Right?
Sure.
What is the business model behind this, right?
Yeah.
So we are looking at rockets, and you are going to launch CubeSat, right?
Yeah.
Which is obviously there'll be lots of CubeSats being launched by market statistics. But compared to the Indian rockets, the SpaceX rocket, where they launch few hundreds at one shot, right?
Yeah.
What's your competitive advantage? What are you thinking about?
Yeah, again, it's the same idea as being on a bus and taking 2 hours to get to a place, and being on a motorcycle and reaching your destination in 30 minutes, in a sense. Yeah. You have to, if you're ride sharing, that is the technical term for being on board of a larger launch vehicle and being a secondary or tertiary payload, because you don't have you don't have the luxury of choosing where that rocket is going to go. The primary payload will determine the trajectory, or SpaceX themselves will determine that, if it's a so-called dedicated
that's my path,
rideshare.
my main things go, and
Exactly.
you're just the sideshow.
Exactly, and that is the trapping of launching stuff with big rockets. Sure, SpaceX can be bragging about charging people $5,000 per kilogram, but that is not what a small satellite operator sees on their invoice. What a small satellite operator will see on their invoice when they have no choice but to go through an intermediary will be vastly higher than that. You know, I cannot really give you an exact figure, but we're talking about closer to $100,000 per kilogram for a small, very small payload. And it's actually better to deal with a smaller launch service provider in that sense, because it offers you more flexibility. You don't have to wait for 9 months for a launch opportunity, for instance, and you don't have to spend 9 months worth of salaries on your company before you demonstrate your technology in flight and get more investors or clients. You can actually choose which exact orbit you want to go into, depending on, of course, on the launch side and you know, the flexibility that comes with the launch side. That's another thing that we want to address, because we want to do a sea launch. And on top of that, there's always a question of availability. Will you even find the right launch opportunity within your stipulated time frame? There's plenty of entrants who are trying to get that done, but companies left and right are struggling with launch frequency right now. And that boils down to one simple problem. Liquid rocket systems are complicated and they are not mass production friendly. Even established businesses like Rocket Lab have had some challenges ramping up their manufacturing, and this is something that we are addressing right from the start, because our stuff is really straightforward. And we will be able to also reduce the risk, because, again, there's very few things that can go wrong with a hybrid rocket motor. The one thing that can go wrong is, you know, if you mess up something with the pressurized oxidizer tank, and you have to be very careful about that. But aside from that, well, we're talking about a drastically lower baseline cost and risk right from the start.
Okay, right. So one of the things that SpaceX claims is obviously the reusable rockets, right? And that's where they can bring the cost down. So what's the answer to that? I mean, is it?
You know, I mean, sure, reusability is going to be the future, but reusability doesn't come free. The one thing that companies simply flat out refuse to disclose right now, because they really don't have to, is the maintenance cost. What is the cost of refurbishing your booster after every single mission? Sure, it may be $1 million, it can be $5 million. I just don't know that number right now because it's not made public.
Yeah, sure.
Yeah, so that's one consideration. The second one is that it will be quite difficult to make the second stage reusable, because it goes much faster. It builds up velocity up to orbital speed, right? And at that point, having it re-enter will encounter much more heating compared to trying to re-enter a booster that just goes very much, you know, like this, you know, which is basically just in a suborbital trajectory, and that causes troubles with heat shields. You know, you basically have to implement a fairly heavy heat shield to survive that kind of re-entry conditions, and that messes up with your mass fraction, which reduces your payload capacity. And it's a very uneasy trade-off situation. I think eventually there will be, depending on the mission profile, there will be some reusability, and there will still be a demand for expandable vehicles, which can be just so straightforward, you don't even need to reuse them, because you can make another one in its place. Yeah, sounds wasteful, but, well, as long as you don't carry anything that's actually toxic on board, you're just really contributing to a new coral reef somewhere in the ocean.
Okay. Yeah, it's sometimes very ironic, right, that in the early days of refrigerator, we want it to last as long as possible, and suddenly we don't want it to last as long as possible because a new model, and then we now are talking about recycling, and just the cycles keep coming back. Now, let's talk about like the professionalizing the firm, right? Yeah. You're a young guy, and your staff that you are now working with you, professionals, 20, 30 years of experience. Yeah. How do you manage them?
Well, I don't manage them.
You don't manage them?
I don't manage them. I bring them what they need, which is basically resources and I bring contracts and deals. That's my part of the job. I don't pretend to be an engineer. I do have to help out with whatever I can because we have limited workforce right now. But that is a very interesting situation when you have so many senior engineers, so many greatly talented people working with you, and then you really find yourself to be the dumbest guy in the room all of a sudden. And then you have to find your footing and just specialize in something, which in my case is really the business development aspect. And of course, fundraising. That's another thing that you cannot really delegate to anybody else as a CEO.
Right.
And well, this is what I do. Maybe in my next life, I will get to go through an engineering course and be more hands-on. I wish I was right now.
No, don't worry. I'm an engineer, but you're much better. You build a rocket company.
Oh, come on.
Now, let's talk about the experience. I think you briefly go through that rocket, right? So maybe bring us through, right? For example, the latest experience of shooting up the rocket. What are you trying to achieve, and how do the process of getting it done?
Yeah, so again, Jamie himself, and afterwards, we did a bunch of ground tests with that particular solid fuel.
Right.
And
I remember that you did one horizontal at a house.
Yeah, we've actually done a bunch of them. Yeah, I have this house over in JB, and we were using it as a bit of a test bed. Yeah.
Let's not go into that.
Yeah, that's a story for another time. Yeah, but so we knew that we have to demonstrate that solid fuel in flight, because again, one of the biggest problems with hybrid propulsion is lack of structural integrity of the solid fuel, right? So we were actually getting ready for that test flight in early 2020, because we've done the ground testing campaign back in October and November 2019. We started working on that on the airframe. We've put together an avionics spec, which was a little overcomplicated for the application, and we had some problems with it, but again, that's a story for yet another time. And this is the funny thing, because it coincides with the entire hell that we all went through since 2020. We were gearing up for a test flight in one of the other countries, not in Malaysia. We were actually working with one organization in somewhere else in Southeast Asia about using one site. We already had everything booked. We had our flights and our hotels and our rental vehicles and all that, and suddenly, the deal fell through. It didn't work out. So I drove up to KL. Again, that was the good old times when you could just cross the border and go and settle your business without anyone prying into your matters, and your nostrils either. I connected with this group that builds some flares in Malaysia, because their main area of expertise is maritime, but they also work on some flares for maritime use, and they do have some space ambitions. And I've connected with them through my advisor, who is another Malaysian gentleman. And I met them, we agreed to work together, and they started scouting for a test location. So they've identified this really nice rice paddy, not very far from Ipoh. And we were supposed to go on a recce, and that's when I was diagnosed with COVID, so that didn't happen. And 3 days later, the whole world just went into a shutdown mode. Okay. Yeah, and I remember sitting, in that hospital room, that ward. I was fine, so no worries about that, but they still isolated me.
I text you, are you doing all right with your COVID?
Yeah, just no worries. Yeah, and I was watching at this horde of people just rushing across the causeway before they shut down the border, like 2 days later, and I was like, what are we gonna do now?
Right,
yeah, so of course then there's circuit breaker. There was a lot of challenges along the way, which again just make this even more painful and difficult. I didn't really have a place to stay for a very long time, and then we lost our office because we were running out of funding, and we had to move to this co-working space where we finished up the assembly of that rocket, and we still brought it over in December on this reciprocal green lane when it was still available, and we did that launch because we needed to demonstrate that technology in flight.
Right.
That was just so desperate, but to sum it all up, it was testing.
Yes, everything should go down, but
it was extremely taxing on everybody. Yeah. And in moments like this, you really can appreciate having a strong team behind you, because otherwise there will be no way you can pull off that sort of feat when the whole world literally seems like it's going up against you, and it is going up against you. And you know that, well, you have to hit that milestone, otherwise no one's going to take you seriously, and you do it against all odds. Mm-hmm. So it really makes, it trains you to have a lot of endurance.
You must have the passion to see yourself through.
Yeah, obsession almost.
I think the passion and the perseverance that comes with it. Yeah.
Yeah.
Okay. So maybe talk about the launch itself.
Yeah, so that was quite amazing actually, because you know we were doing some troubleshooting all the way until the evening before the launch, and you know we drove down to this. You know the rice paddy at that time of the year was flooded, so we had to go to another site nearby, yeah, which is this huge palm oil estate. And you know, I personally drove that lorry with no seat belts in it, you know, from KL all the way to Perak, to the site, and we arrived in the middle of the night, like 4 a.m., pitch black, quiet, no wind, and then we just ramp up those generators that we brought with us, and we start getting ready. We start assembling the launch tower. We start assembling that, doing some final assembly on the rocket, and by the time it's sunrise, we didn't sleep for like 3 days straight at that point. And then people started to arrive because our Malaysian partners invited a bunch of spectators to come down. And that was awesome. Yeah, they were all super enthusiastic about the whole thing. Right. And yeah, it took longer than we expected to get ready for that launch. We had only 20 minutes of the NOTAM left. You'll be well familiar, right, with what NOTAM is. Yeah, yes. Notice to Airman. Basically, it's a clearance to use an airspace for a specific application for a while.
So you booked that hours?
Oh yeah, that was fully legit. We actually had a NOTAM. We had a permission from the local landowner. We had clearance from the local police because we were using some pyrotechnic deployer for the parachute. And we also had an ambulance in standby, so it was not some,
You had a fire engine standby?
Yeah, just ambulance. The fire engine, I was the fire engine. Okay. I'm the guy with the extinguisher every single time, yeah. Okay. Yeah, that's my job during tests. Yeah. And yeah, 20 minutes before 12, which was the point of, the cutoff time, yeah, we finally managed to light a candle, and, once it went up, the sound was just absolutely incredible. One of those moments that just sears into your memory forever. Mm-hmm. Especially, even more so with all the fatigue, and even more so with all the challenges that you still remember so well that you had to deal with just to get to that point. And, I'm probably hooked on that, you get addicted to that.
And the grandfather too to come.
Oh yeah, oh yeah.
Now, so it goes up 1.2 kilometer.
Yeah.
Successful launch, right?
That's right.
Okay, so I believe you have the telematics data. So what is the next challenge?
Our next mission is going to go up to more than 60 kilometers actually, and yeah.
60 kilometer.
It's going to go supersonic.
I think at 50, is it at 50 kilometer we consider that you are human that passed 50 Kármán line?
Well, the Kármán line is roughly at 100 kilometers.
100 kilometers.
Yeah, yeah. So we're getting 60. Close to that. Yeah.
But the American standards say above 60 kilometers is about there.
I think 60 kilometers will already get you like the Air Force astronaut wings or something, because they were doing those X-15 flights, and they were going to like 50, 60 kilometers. So in their definition, that's already good enough.
All right. Okay.
If I'm not mistaken, don't quote me on that.
But 50, 60, is that your final?
Oh, absolutely not. This is the next step.
Yeah.
It's to test the same solid fuel in supersonic flight conditions with much higher accelerations.
Supersonic, and
it's going to go to Mach 3.5.
Mach 3.
Yeah.
Okay.
Yeah, it's not too bad.
All right.
And yeah,
not bad. It's fast.
We'll be carrying some payload on board. We'll take some some badass footage from that mission.
Sure.
And after that, we're going to develop a fully commercial suborbital rocket, which will carry more than 25 kilograms of payload above the boundary of space. There is some market applications for that, but it's also going to be partially a stepping stone towards our orbital-grade launcher that we call Volans, that we will be developing later this year and in 2023. We'll
that's pretty fast.
Well, it's about time. We are working with, with people who have over 200 years of collective experience in relevant engineering fields. And it's not just propulsion, it's also aerodynamics, it's also structures. It's, in preparations for our sea launch capability, we have a gentleman who spent 50 years in maritime, in the maritime business. We've got people with experience in guided systems and avionics as well. So, plenty of good things going on.
Great. So the guidance system must be great. We are not using an Arduino, right?
Well, not for the orbital launcher, no.
Okay, maybe a couple of questions. I'm not sure whether it applies, but yeah, this guy asks, the hybrid rocket engine is also used by Richard Branson, Virgin Galactic, right? And for space tourism. So is there an advantage of your hybrid motors?
Yes, because again, you don't carry explosives. Yeah. If you carried, for instance, purely liquid propulsion system, then it's of course drastically more expensive, and we can tell that very, very clearly from the price point that Jeff Bezos is putting on a seat on board of his rockets, which also do a suborbital tour flights. The funny thing about Virgin is that they actually have two different companies under the group. One is called Virgin Orbit, and they do orbital launches out of a 747. They have one of the modified 747s, ex-Virgin Atlantic, and they actually operate it out of Mojave. And they have a liquid propellant system on board of that rocket, and they just do an air launch with that, and they go into orbit.
So how do you carry that?
They basically...
On the 747 on top? Or
no,
below?
they modified, there's this extra hard point for extra engines. That I think they put that specifically for Qantas, so they can ferry extra engines back and forth. Okay. Yeah, so they use that hard point to attach a launcher. It's pretty awesome, actually, what they do. And the other company, the space tourism company, Virgin Galactic, does in fact use a hybrid because of its, again, price point and the safety that you get out of it compared to using an explosive device on board of your vehicle. If they use our solid fuel, they could go into a much higher altitudes because it's it's more energy dense, and it's also again has better performance. Who knows? Maybe we will end up doing some cooperation with either Virgin Galactic or any other company in the future. I did speak to some of the heavyweights and floated them the idea of using our technology as boosters or strap-on boosters to boost their performance. And yeah, we do have this thing going on in the background.
So there's a specific question. Say, what if people on the liquid fuel side want to use a hybrid? Would they copy you?
Yeah, so we are filing for a patent for that solid fuel, of course. We'll have some protection, but is it possible for us to just sell rocket motors to other companies? Absolutely, yes. We could. That would mean that every one of those companies have to do some drastic changes to their systems architecture, but we could do that, and we could in fact become an engine supplier. The reason why we are still bullish on our launch platform instead is that we have concepts how to innovate not just with propulsion but also with avionics and also with structures and materials. So we want to have a much more comprehensive product than just relying on one piece of hybrid rocket propulsion technology. So yeah, we have a longer term vision with this and plans.
Okay, so let's say moving on, rockets, and then after that more rockets, and then go to space, right? Yeah. You need a lot of money, right? How are you going to raise funds?
Yeah, well, so in this line of work, you have to prove yourself with different milestones. Of course, we started off from very little resources, but the more we did, the more data, the more traction we had with potential clients and also with potential investors. So you really have to take it in a very incremental approach. And well, it's a never-ending story, fundraising as a startup, but throw in some rocket science into that and you're in for quite a ride. It's, well, as I said before, it's predominantly my job to be doing fundraising, and different investors really have different expectations from you.
Okay, so maybe you start a rocket company in Singapore, right? Where nobody has ever invested in rocketry. Yeah. So maybe we can take a look at the global picture, right? And which places is more suitable for funding fundraising,
well,
for these kinds of stuff, right?
Well, definitely the US. They have plenty of things going on.
So where are the places that we should know if somebody want to build a rocket? Where should the places?
Yeah, I would recommend Southern California for that. You will find plenty of engineering talent.
Southern California, a big place. San Diego, nice.
Well, San Diego is nice for retirement, from what I know. But
But where's a good place?
Well, LA is where plenty of those smaller rocket companies are setting up. Just to name a few: ABL, Rocket Lab, Relativity. They all have deep presence over there. They all have their headquarters over there. Virgin Orbit as well. So there is an environment where there is essentially they have a whole ecosystem in place. If we want to test a rocket system in here, we have to really struggle quite a bit trying to find a place to do it.
But it's very funny, right? LA, right? It's a congested place.
Yeah.
Normally you find rocket company in way off place.
Yeah, the thing is, you don't have to do everything in LA. You do your manufacturing, or at least part of the manufacturing and design work over there. Then you do some assembly and you bring it to another site for testing. SpaceX, for instance, has a ranch of their own over in Texas, in McGregor. That's where they bring their prototypes and do their tests. Recently, they've set up another one over in Boca Chica, also in Texas, where there's plenty of very affordable real estate. Some smaller companies like ABL bring their stuff, bring their rocket motors to test them over at Mojave Desert, which is just a couple of hours outside of LA. And believe me, you may find it difficult to believe, but LA, with all their traffic going on, both on land and in the air and at sea, they actually have a spaceport quite nearby called the Vandenberg Air Force Base, where a bunch of those companies actually fly from. So yeah, that's what I was hoping that Singapore could actually try to replicate, because we do have fairly attractive locations over in South China Sea, nowhere near the disputed areas, so you don't have to worry about that, and we are close to the equator, and that could be a very interesting place to operate from. So that was the intention right from the start.
Yeah, you see a spot in South China Sea where you can shoot it up from the equator, but people are worried about commercial airliner flying all across.
Well, there's room. There's plenty of room.
There's plenty of room.
There's not so much, well, it looks like we may have been a little early, ahead of our time in that sense. But yeah, there is some talk about doing that in the background. But it's still going to take some time before something like that happens.
Yeah, it's difficult, especially we don't have a tradition of building, not like the backyard rocket, you can just shoot up and then you have this culture.
Exactly. That's a very important part, actually. STEM education is critical, of course, but plenty of engineers really get started with their own little hands-on projects when they are teenagers, and the same applies to many of the senior engineers working with me. They had the chance to start working on some fundamentals when they were 14 or 15 years old, and they could, of course, keep upgrading their skill sets and get more and more experience in the process.
Yeah, Michael, we have an online course that is building rockets. All right, online course, but water rockets.
All right.
But at least get you the principle.
Absolutely.
Get it moving. So attend the online course.
Yeah.
All right. Okay, so maybe last word. Moving on.
Yep.
What are you going to do for the next couple of months?
Well, the next couple of months will be really focused on doing this upcoming test flight, the 60-kilometer demonstration vehicle. It's the most important piece of technology we have under preparation right now. It's going to get us to technology readiness level of 7, at which point we'll be in the forefront of what's going on in commercial space. I think we could also, instead of the next few months, we can talk about the next few years, in fact.
Okay.
Because with hybrid rocket propulsion, we are not necessarily limited to small satellite and dedicated launchers, something that's fairly compact. We can and we will build much larger rockets as well. And we are going to go after the heavy lift market segment in due time, except that our price point will, pretty much by default, will be half of what other companies are charging, even for heavy lift.
You're going after SpaceX.
I'm not saying that. That's not what I'm saying. I'm saying we will go into the heavy segment.
Yeah, heavy segment. Yeah, okay. Yeah. All right, so that's good. And I think maybe you can come to the close of this this session, right? It's a very unique case here where you know, you dream of something that in the environment is almost impossible to happen, right? And then you make it happen, and you are on the way to doing that. So what's a word to the young girls, young boys out there, and says, if you have a dream, what should you do?
Go into banking. No, I'm just kidding. Well, you know, it's the only person who really puts, you know, any limits on you is yourself. It's corny, but it's true. And you know, you never know what you're capable of doing until you actually go out and do it. And every single moonshot, every successful moonshot starts with a dream and a vision and determination. Just one word of warning. If you're into entrepreneurship of all kinds, if you're especially into aerospace entrepreneurship, it's going to get tough. Trust me. If I knew what I know now, I would think twice about getting involved with all this. I think you can relate, right?
Yeah, I can see when you start to now, but you know, I'm actually quite amazed because
Thank you.
when you talk to me about you're studying these rockets and a company. Before that, I think you want to start a beer company.
I did work. I did have a very, very small business. Didn't make any money. In fact, I wasted everything.
So
but
before that,
I was importing beer from Poland. Yeah,
and then you're talking about rockets, and I was like, what are you doing? You are real estate guy, and this rocket is real hard engineering.
Oh,
right?
There's plenty of real space out in space.
Yeah, and yeah, but then I can sense the passion when I talk to you, and you start explaining the South China Sea, the space, the launch pad, almost like SpaceX replica in such a small thing, right? Launching it from the sea with the sea platform.
Yeah.
Sounds very, very exciting. I'm very skeptical at that point in time
I
because
remember
I say how airlines are flying over there and you were going to launch it. But then there's always a way, right, for us to move on.
Well, you know, just really one piece of, you know, just one closing, you know, thought to share. Just make sure you're doing something innovative. Don't just copy and paste something that some other company or your idol have already done. Contribute to the grand story of humankind and human technology by doing something novel. All right, and if you do that, then yes, you will have a much better shot at success. Because otherwise, if you're just a copy and paste of somebody else, how are you going to compete with them?
Well, with that grand vision and that great statement, I think we'll end this session today with Simon, and we will keep track of you.
Thank you very much. Please do.
And launch of your rockets.
Thank you for having me today.
And got to remind you, he still do his national service. All right, thank you very much.
Don't remind me, please.
Thank you, Simon.
Hey,
thank you
so very much. Thank you.
Bye.